Okay, so let's quickly review what we have done so far. Okay, we said that our data should be stationary. Okay, so let's first load. Ano ginamit natin yung Apple, no? Okay, we're using the quant mode package. Sa quant mode package, you can easily download any data, whether it's data of stocks or data, macroeconomic data. Okay, so here, i-ano ko lang to, plus i-close ko lang lahat, no? Alright. Okay, so this is a quick review, no? Start date natin 2010-11. I'm not sure if this was the one that we used, but in my notes, ito yung ginamit natin. So from, actually we can use ano na lang, 2007, no? Para lumabas din yung ano yung global financial crisis. So 2007-01-01 and date 2022-12-31. Okay, and then we're going to use the quant mode package. We're creating this object Apple, and then we're using the get symbols. The data, the stock is Apple, the source is Yahoo. Start date is from is equal to start date, which is this one. End date is end date. Auto dot assign is equal to false. That will allow us to create an object with a different name. Otherwise, kasi kung auto dot assign is equal to true, which is the default, mag-create siya ng object na ang pangalan aapl. Dito ang gusto ko, mag-create siya ng isang object na aapl yung pangalan. Okay, if I run this, okay, let me pause for a while and ask you if you're able to generate, no? Ang suggestion ko, siguro i-sweep nyo muna lahat ito, yung mga objects na na-create natin dati para bago. Okay, so we have this object, Apple, end date, start date. Okay, and then we can, we have the object now. Okay, if I view this, alam natin na sa quant mode, pag galing sa Yahoo, OHLC yung ibibigay sa atin, open, high, low, close, volume, and adjusted. Okay, so this is from 2007. And then if you take a look at it's up to 2022, 12:30. Okay. So what we're going to need only is the closing prices lang gamitin natin, no? So, hindi closing. So dito, we are going to subset. We're creating this object, ADJ, Apple, adjusted price ni Apple. And then we're subsetting only the 6th column. So take note, si Apple natin, ito. And if you want to create an object which consists only of just some columns of the original data, you can do that, no? Yung bracket natin. So 1, 2, 3, 4, 5, 6, this is the 6th column. So if you take a look at this, we're creating this object, ADJ, AAPL, the 6, Control C, i-share ko na lang dito sa chat in case you don't have it. And then I'll need your feedback, class, no? Kung nakukuha nyo or am I going too fast, etc. No? Okay, so what's this code? We're creating an object called adjusted Apple. So it's from the Apple data set, and then we're subsetting only the 6th column. So if I show this, kukunin lang natin adjusted, no? Just the last column. Okay, and then, okay, i-view natin siya, and then papalitan natin yung column names. If I run this first two, I run the first two. Okay, what happened? Bakit nag-error to? Na-run ko na naman to. Okay, andyan na si Apple. Tapos, here, I'm creating this object, ADJ, AAPL, 6 column lang. Tanggalin ko na muna to. No? Column names, ADJ, AAPL is adjusted. Okay, it's okay, Kim. All right, so if I run this, okay, so meron na tayong panibagong object, ADJ, AAPL. If I view this, yan, no? ADJ. I also changed the column name. Okay, ADJ. All right. Okay, so far class, na-generate ba yung adjusted apple na adjusted apple na object? Feedback, please. Okay, I have your feedback for those of you who are following along. So dapat may object na tayo na ADJ AAPL. Actually, I don't like the name, ang haba. Mamaya palitan na rin natin. It's a long name. Okay? All right. Yes, sir. Okay, sige. Thank you. Now, gawin na lang natin class na na kasi masyado mahaba yung ADJ. No? Let me just, okay. Actually, ito, pwede na lang AAPL na lang class, no? Or dito, we can AAPL, and then ADJ, AAPL. Okay, I'm going to create an object called AAPL, which is the adjusted AAPL. So, ang mangyayari nito, yung AAPL natin, which consists of OHLC, volume and adjusted, it will be overwritten by this AAPL. So, the adjusted AAPL will still be there. Magka-create lang tayo ng isang object na ang pangalan AAPL, and it will be the same content as adjusted. Okay, so take a look. So, ito na yung AAPL natin. So, yung dating AAPL natin class, if I open this, wala na, no? Kasi in-override ko na yung dating AAPL. Okay, so I'm just interested in the plot of AAPL. Okay, so you can see here, it's AAPL, adjusted prices to, no? Definitely, class, this is not stationary. Hindi siya stationary kasi may trend siya, umaakyat siya. Okay, so you cannot do an arima model out of this, right? Kailangan muna ma-convert natin, ma-transform natin itong data na to so that we can generate an arima model out of this. Okay, in the next here, pwede rin naman natin gamitin yung yung autoplot function. Okay, so this one, pareho lang naman yung plot na yan. Okay. So ggplotly p1. Okay. So nag-generate siya ng plot. Ang difference lang nito class, nitong P1 na to na autoplot, this P1 is static. Okay, so what's P1? We're creating an autoplot for Apple. Naglagay tayo ng title niya at saka yung label ng y-axis. And then we printed P1. When we print P1, notice, class, that P1 is just a static plot of, okay, if you hover around the data, okay, static plot lang yan. Now, if we convert our P1 into a plotly object, yan, so ito, plotly, if I run this, okay, so ganito gawin natin, no? I'm going to create an object called P2. Okay. Kasi si P1, it's a list, diba? It's a list of 9. If I convert now P1 into a ggplotly, I'm creating P2. Right, and then print P2. And then you can see now that magkaiba si si P1 at saka si P2. P2 is only a list of 8. Yan. Ito lang siya, no? Pero iba yung laman niya. Okay, tingnan mo yung mga laman ni P2. Merong mga sizing policy, dependencies. Si P1, if we run P1, okay, di ba iba, no? Iba yung laman ni P1 as an object and P2 as an object. Kasi, class, P2 is actually a plotly object. So this is one of the most powerful plotting now, yung plotly. Kasi, ano siya, tingnan nyo, interactive siya. Unlike yung P1, hindi interactive yun. Diba? May zoom into, may zoom out, and then you can download this as a PNG, etc. May mga functionality si plotly. Ito. Unlike yung P1, hindi. P1 is just a static representation. Si P2, I'll run this both. Yan, so this is P1. Okay? Hindi siya dynamic. P2 is ito. You notice yan. Dynamic siya, no? Pwede kang mag-zoom. You can go to a certain portion and then yan, naka-zoom siya, no? Yung portion na yun, etc. Okay. So, another way to plot, so quick review lang to, class. We're now using aapl, sorry. This is another way to plot. Okay. But that's not our concern now. Our concern is to create an object, a model out of that. Now, we would like to predict. We would like to predict yung Apple natin. Okay. So, paano natin minomodel, class, yung Apple? There are different ways to model this. Usually, ang minomodel, hindi yung prices. Okay, so what we have looked into so far is try to model yung price ni Apple. Okay, but sa finance, we're more interested in modeling yung returns, no? Yung returns ng stock. Okay? But let's first take a look at the Apple data set itself. Okay, so here, sabi natin, i-model natin yung Apple stock. Huh? How do you model that? Okay, di ba sabi natin, nung plinat natin, hindi siya stationary. So we will have to convert that, to transform the data. So how do we transform that? Sige, so let's create this object, DAAPL, which is the difference of, we will have to change this, DAAPL. Okay, so I'm creating this object, DAAPL, difference ng AAPL, no? And ito yung function niya, difference AAPL. So what it's going to do is, it's going to generate a new time series, okay, where magkakaroon ng subtraction, differencing. So 2.6 minus 2.54, 2.58 minus 2.6. So, i-difference siya. Okay? So, magkakaroon ng NA dito sa first line kasi ito, walang previous value. So, that's what happens when you difference. Okay, so take a look at this. Pakibago na lang baguhin natin yung yung mga variables. So, we're creating this object DAAPL, difference AAPL. And then when we print DAAPL, view natin siya, you notice now that there's an NA here. No? Bakit may NA? Kasi wala tayong prior value. Now, that's very important kasi hindi ka pwedeng, kunyari, no? If I try to get the mean, let me put it here, mean ng DAAPL, can I get the average of the difference data set? Okay, the answer will be NA. Bakit? So, R will force you to look at your data kasi may NA tayo. So, hindi siya nag-automatic na tinanggal niya yung NA doon tapos kinuha niya average. So that's a default of R for you to look at your data. Bakit nag-NA? Kasi may NA tayo. No? So what we can do now is we can remove yung NA. No? Paano natin i-remove yan? Well, very easy. Iisa lang naman yung natin. Iisa lang naman yung data natin, yung DAAPL. Isa lang siya. No? It's only one column lang. So, and several rows. So what we can do here is just remove we don't have to put 2 here, kahit isa lang, no? Bakit isa lang? Kasi understood na yan na tatanggalin natin yung first row. Why don't we have to put anything in the column? Kasi isang column lang naman eh. Alright? So let's replace yung DAAPL natin, ano? DAAPL, so I'm creating this object which is just DAAPL, then -1. Ibig sabihin si DAAPL natin, tinanggalan natin yung first observation natin, yung NA natin. Okay, so you can now get the mean. If you get the mean of this, mean of DAAPL, this will not work. No? This will not work. Okay, yan. Nakuha na niya. No? 0.03155. Okay, let me pause for a while. And please chat if you were able to follow so far. Gandito, no? Okay, thank you. Yeah, quick review lang to kasi dapat umabot tayo ng gusto ko lang din, I'm deliberately reviewing this kasi ang observation ko, pag matagal tayong hindi nag-meet, there's a tendency to forget this. So I hope this will serve as a quick review. Tapos, kung hindi natin aabutin, I'm sure aabutin namin sa kabilang section mamaya yun. So, ipopost ko yung parehong videos, no? Alright, so there's an alternative way here. I just want you to look at that. So ito naman, ang ginagawa lang, sinasubset lang si DAAPL from row 2 hanggang dun sa dulong row. So actually, hindi na kailangan to. Ayan. Bakit isa lang? Bakit hindi natin kailangan i-define yung column? Kasi isang column lang. So that will be understood. Okay, I'm just commenting that out. Alright. So, i-plot natin ngayon si difference na AAPL, si DAAPL. And we can see now that it is now stationary. Stationary na siya. Yung DAAPL natin. Stationary in mean. In variance, medyo sabi natin may problema tayo kasi dito sa last part, dito sa 2019, most probably COVID to, no? Meron tayong fanning out, no? Yung difference na data natin, no? Hindi siya constant in variance. So that might be a problem. All right. Now we said that this is another way to, kasi transformation ng data ang ginagawa natin, no? Now we ask the question, what if we get this time the log of the difference AAPL? Okay, kasi class, anong nangyayari, if we get the difference of a time series, it will address any trend, no? Makita natin nawala yung trend, di ba? Nawala yung upward trend. When we got the difference, nawala yung upward trend. Pero it did not seem to address the variance, no? Sabi natin a while ago is that yung variance medyo constant siya dito sa portion na to, pero pagdating dito during the COVID area, naging very volatile na siya, no? Okay, the series, that's the difference of your data. Okay, so what if we let's try to address that non-constancy invariance. So what do you do with that? To address a non-constancy invariance, pwede natin gawin, kunin natin log. Kasi yung log, scale yung data natin, and then it might address the non-constancy invariance. So I'm going to create this object, log LDAAPL. So I'm going to get the log of the DAAPL. Okay, wag na natin okay. Sige, i-view natin. So let's run this. Okay, ano mangyayari, no? What happens is that it will generate not a number. Okay, and we said that this happens because yung DAAPL natin, which is this one, may mga negative siya, no? There are negative values there. And you cannot get the log of a negative number. So hindi pa pwede ito. Okay, magka-create siya ng mga not a number, mga undefined na mga numbers. So what's usually done in order to address yung non-constancy invariance? Reverse natin yung process, no? You first get the log and then you get the difference. So that's what we did here. Okay? So dito muna, kinuha natin yung log ng AAPL, palitan natin to. And then i-view natin siya. Okay? So let's run this. We got the log. So it gets the log of each of the numbers. Ayan, no? And you can see there the values. And then if we plot the log. Ayan. So what happened here? Okay, if there's one thing, it did not address the trend. So non-stationary pa rin to. Kaso medyo bumaba yung yung non-constancy invariance, medyo nabawasan siya. Okay? So if we're going to plot the original AAPL, as an AAPL, ito, no? If we plot the original AAPL natin, yung adjusted lang yan, di ba? Plot AAPL. You can see that our AAPL, okay, you can see that aside from the trend, sa portions na to, medyo, di ba, non-constancy invariance. Compare that with the log AAPL. Log AAPL, ando dun yung trend, kaso medyo nawala yung non-constant, na-address ng konti, no? Although may mga portions pa rin na makikita natin yung apparent, katulad nitong 2007, 2008, ito, medyo malaki yung no, yung drop ng variance. This was during the global financial crisis. Okay. So in order this time to address the trend, kukunin naman natin we'll get the difference of the log. So ito na yun, no? So we get the difference of the log AAPL. So difference ng log AAPL. Okay, wag na natin, sige, i-view natin to. Okay, so again, since we're getting the difference, meron tayong NA sa simula at the start. So tinanggal natin yung ano niyan, you can also use the NA.omit. Okay, pwede rin to, no? NA.omit function ng difference na log AAPL, and then plot natin to. Right? Tinanggal niya yung inomit niya yung first line, which is NA. Okay. And then you can see here, class, that okay. So getting the log, no? Okay. Definitely yung trend niya na-address, no? Kaso nga lang meron tayong seasons of yung volatility clustering ito. This was during the global financial crisis and this is during the COVID. Okay, so meron pang ibang areas na medyo may which we call volatility clustering. So when it addressed the trend, it did not really perfectly address the non-constancy invariance. Okay, but yun na lang magagawa natin, no? Be that as it may, i-model pa rin natin. Okay. So, now ang question dito, ano ba yung model natin? Okay, so first, let's first test kung yung kung yung difference na log natin, ito yung and I discussed this before, sabi natin, itong difference na log AAPL, this is actually the returns, no? We can show that, okay, just pakita lang natin DLLAPL, saan na siya? Ito, no? Ito, di ba? 0.0219, okay. And then let's create another object. Dito natin lagay, here. Just to compare it with Control I. Okay, so I'll create this DLAAPL1, okay, which is, di ba meron tayong function na daily return. Daily return. So this is from quant mode, no? Yan. Daily return ng anong object natin. Daily return ng class. Anyone? Ano yung isa-supply natin dyan? Class? Tignan nyo, no? X, subset, hindi naman, kasi wala naman hindi naman natin na subset. Tapos type, no? Type. Dalawang klase, either arithmetic or log. Okay, so how do we do this class? So yung object natin is your AAPL. AAPL. Ito yung adjusted prices natin. To get the daily return, okay, and then, yan yung X natin, tapos type natin is equal to log. Okay, so take a look at this. We're creating this object, which is actually DLAAPL, and then we're going to compare it with DLAAPL. Okay, and then let's view this. D log AAPL1. Okay, let's run this. Okay, so tingnan natin to Your DLAAPL1, this is 0.0021952292, no? Ito 0.00219522. So pareho siya dito. Okay, balikan muna natin to and then what we're going to do is lagay natin dito NA para isang anuhan na lang. NA.omit. Tanggalin na natin yung first line na no? the first line, which will have walang value siya. To take a look at this. Okay, kasi wala siyang previous na na data. And a dot omit natin, tingnan natin to. Alright. Hindi niya tinanggal, no? Okay, so dapat talagang physically tatanggalin natin. Okay, let me. So this will not work. So dapat tanggalin natin yung first row. Control C, Control V. -1. Yan, okay? We're removing -1 kasi dito sa daily returns, binigyan niya ng value, ginawa niyang 0. Dapat walang value yan eh. So we're just going to delete this. Okay, remove it. And then view natin. Okay, 219. Compare lang natin, plus. Head ni DLAAPL, yung first 6. Head DLAAPL1, first 6 then. Okay, what am I doing? I'm getting the first 6 observations, the difference log AAPL, and then yung DLAAPL1, which was generated by using the daily return function in quant mode. Okay, let's see if they're the same. Run natin. Okay. So if we compare, 0.02195992, pareho. 0.7146902. Okay. Everything is the same. Okay, so ang gusto ko lang pakita dito, class, that getting the difference ng log ng object natin, ng data natin, is actually getting the log returns. So the log returns is equal to getting the log first and then getting the difference. Okay, so daily returns, daily log returns, which is this one, yung AAPL object natin type is equal to log returns, is just the same as getting the log first and then getting the difference. Okay, I hope that's clear, class. Paki-chat naman please kung okay tayo so far, kung clear. Okay. Okay. All right. So okay, now we first have to check, no? If we plot the difference log AAPL, alam naman natin na mukhang stationary na siya. But there's a statistical way to test that. And we make use of the ADF test, no? Augmented Dickey-Fuller test. ADF test. So this comes from the package T series. Okay. And then we test if this series, DLAAPL, has a unit root. Ano ibig sabihin ng has a unit root? Ibig sabihin ng may unit root siya, ibig sabihin nun, not stationary yung data natin. Okay? Having a unit root means that your data is non-stationary. Okay? If we run this using the ADF test, we have to do this in order to make sure that we're working on a data that's stationary. Okay? And we have here a p-value equal to 0.01. You have your ADF test statistic is -14.406. And then this one, value of 0.01. Okay, what's our conclusion? We infer that our data series DLAAPL is is what? We reject the null hypothesis kasi. We reject the null hypothesis that our time series has a unit root or it's not stationary. I-reject natin yun in favor of the alternative hypothesis that your data is stationary. Okay, so we were able to show that yung difference log AAPL natin is stationary, no? Or we can use of another test which is the KPSS test. Okay, ito a KPSS test naman, opposite yung null hypothesis niya. Ang null hypothesis na to is that your data is stationary. So if we run this, control enter, okay, you can see now that our p-value is 0.1. So conclusion natin dito based on this Kwiatkowski, Phillips, SS, whatever this SS name is, no? We fail to reject the null hypothesis that the time series is stationary. Okay, so ibig sabihin, pareho yung conclusion natin based on ADF test and KPSS test. Pareho yung conclusion natin, ibig sabihin nun, our data are difference log AAPL, which is the log returns of AAPL, is stationary. And so because it's stationary now, we can now generate a model out of that. Okay, there's another test ito, yung URCA, yung unit root.df test. I'll leave you guys to look at that. Okay, so punta na tayo dito sa pag-determine ng ARIMA model. So how do we do that? How do we do that? Let me just get water now. Okay, so di ba ang objective natin? Let's begin with the end in mind ulit, no? Gusto natin i-model yung Apple prices. Kaso nga lang, we just can't model Apple prices. Kasi hindi siya stationary. So we have to do some transformation with it. So ang lumalabas sa transformation natin is get the log difference, which sabi natin, which brings us to the equivalent of getting the returns, no? Log returns. And tama-tama din kasi ang usually sa mga studies, ang gusto naman talaga i-model yung returns eh. We're not really modeling the price of Apple itself, but rather the returns, no? Ni Apple. Okay, so since stationary na siya, pwede nating i-model siya, no? So dati, the first way was to plot what we call the autocorrelation function, partial autocorrelation function. Okay. Do you have this code, class? May I know if you have this code? This one. I'm not sure if I gave this to you. Itong determining the ARIMA model. Okay, thank you. All right. So, ito. I-plot natin, class, partition, number of rows, 1 row and 2 columns. So, side by side niya ipa-plot si ACF. ACF is autocorrelation. PACF is partial autocorrelation function. We're not going to learn how to compute for the ACF. But ang concept niyan kasi ganito, no? Meron tayong time series. Tapos kunin natin yung log 1 na time series. Okay? So we have time series and then kunin natin log 1 niya. Kunin mo yung correlation nun. So may value ka nun. No? Tapos kunin mo naman yung log 2. And then kunin mo ulit yung correlation ng time series natin with each log 2. Tapos yung log 3, etc., etc., etc. So you'll now have your different correlations based on different lags. So that's what you call the autocorrelation function. So mapaplot natin yun kasi may values yan eh. Tapos ganoon din si PACF, medyo may kaibahan nga lang sa pag-compute si PACF. But the bottom line is, you use this because an ARIMA process can best be described by the ACF and the PACF. So how do we do that? When you inspect the ACF and the PACF, pag may significant spike sa ACF, tapos may slow decay sa PACF, okay, let me illustrate that. Generally, ganito, no? So ACF natin. ACF. If the plot of the ACF is like this, sorry. Significant spike here, significant spike, tapos wala na. Yung PACF naman is a slow decay. Ganyan. Okay. Pag ganito class yung ano yung plot ng ACF tas yung PACF ganito. Okay, there's a possibility that this is an MA process. Moving average process. So in other words, yung MA process, tinitingnan natin yung ACF. That's what we look at, no? Pag may mga significant spikes kay ACF, ibig sabihin ng significant spike na to, itong lag 1, yung time series natin at saka lag 1, significant at this lag. At this, nabi natin lag 1 to lag 2, lag 3. So significant siya at the first few lags and then hindi na significant. Si PACF naman, slow decay siya. Okay, pag ganito yung drawing ng ACF at saka PACF, most probably it is an MA model. Baliktad naman, pag ang PACF natin, significant spike, 1, 2, tapos wala na, hindi na significant. Tapos si ACF natin, slow decay, just like this. Then, that's a clear sign that it's an AR process. Okay? Tapos pag pareho silang slow decay, okay? That may be an indicative of an ARMA process. Okay. So, medyo trial and error, no? Pagtingin sa ganyang modeling. Buti na lang may mga functions sa tayo na will determine for us kung anong model. Dati, manual kami. So, ipa-plot namin yung ACF, ipa-plot yung PACF, tapos huhulaan namin, ano kaya yan? AR process kaya yan? O MA process yan? Tapos iteration. Okay? Co-compare natin AR1 kaya yan, AR2, MA1, MA2. Co-compare namin yung mga models na yun. And find out, based on a certain parameter, kung ano yung best model. Usually, we base it on the AIC, yung AIC information criterion. Pero ngayon, class, madali na, no? Kasi meron na tayong mga functions na ibibigay sa atin yung tamang model, no? Alright, so take note here, ang ginagamit natin model yung ang pinaplot natin yung difference log AAPL. So this is the log returns, di ba? And can we model that? Yes, because that's stationary, no? Sabi natin dapat stationary yung data series natin. So I'll now use the ACF and the PACF function. Ito, ACF, difference log AAPL, and then we give it a name, and then dito din PACF. Okay, so i-run natin to. Okay, take a look at this. It will now give us a plot of your ACF and PACF. Okay, so the difficulty with this is that ang hirap. Okay, medyo ang hirap. Yung dalawa na lang. By the way, ang ibig sabihin itong par, this is partition, no? Rows, 1 row and 2 columns. Pag binaliktad natin to, 2 rows and 1 column, ano lang yan, yung partitioning lang ng plot natin. Okay? Yan. naging ganyan, no? 2 rows, 1 column. I'll just make it 1 row and 2 columns para mas kita natin. So don't be intimidated by that. Partitioning lang yan ng plot. Okay. So dito, class, mukhang no? You have here significant spikes at log 1, log 2, 3, may log 4. Yung mga lumalampas dun sa sa blue line na yan, those are significant autocorrelations, no? Ayan, dito sa log 10, 11, 12, 13, 14, 15, no? So medyo kahit na matagal na yung matagal yung log, may nakikita tayong autocorrelation. Same thing with PACF, no? You have significant autocorrelation, partial autocorrelation at log 1, tapos log 4 to. So may mga log, no? May mga significant correlations at different logs. So sabi nga natin, this is difficult to medyo mahirap to, no? Parang ba to? AR process ba to? O MA process, no? Okay. Anyway, let's continue, no? So sabi natin, before, the use of this was to try to figure out kung anong model to, AR ba to o MA ba to. There's another function, okay, this is from the TSM package, which autocorrelation, no? And then let's define the maximum log. We can use 24, you can use 16, it depends. You can use 36. Okay, i-plot din natin to. And the good thing here is that iisa lang yung code natin. Okay? Mas maliit nga lang, pero makikita natin dito yung mga significant spikes, no? Yung lumalabas dun sa dotted line na yan, mga significant spikes yan. So here, based on the AC, okay, ang ganda itong AC class, isang function lang. Dito kasi dalawa pa, no? ACF at saka PACF. Dito isa lang, then automatically pareho na niya ipa-plot. Okay? So dito, you can see here at log 24, may mga significant spikes, no? So, medyo mahirap i-determine kung AR process ba to o MA process. So, usually ang gagawin yan, trial and error tayo. Tapos base it on a certain criterion para malaman kung sino kaya yung best model. Okay? Now, the good thing here is that meron tayong, from the forecast function, meron yung auto.arima. Ayan. So, this will make really the modeling very easy for us, no? Kasi gagamitin natin itong from the forecast model, yung auto.arima. No? Okay. Tanggalin muna natin to, class. Control C. And then dito, Control Alt-I, Control V. Okay, remove first itong trace is equal to true. Okay, so first, this one. No? So we're creating this model. Tawagin natin Model 11 na lang. Kasi may mga Model 1 na tayo kanina, no? Model 11, no? The function is auto.arima. So ang gagawin nito, hahanapin niya yung pinaka-best na model for our difference log AAPL, which is, remember, this is the log returns of aapl. Yan ang minomodel natin, di ba? Okay? How did I know? Di ba pinakita natin na getting the log and then the difference is actually getting the log returns. Okay, so if we run this, okay, so may object na tayo. I-print natin si mod 1. Okay. Mod 11 pala. Mod 11. So what does mod 11 give us? All right, yun. No? So it gives us the suggested model. No? So ano yung model na to? It's an ARIMA model 501. Okay, so ibig sabihin, order 5 ng AR component, at saka order 1 ng MA component. Kaya tingnan nyo dito yung coefficients. No? Meron tayong AR1, AR2, AR3, AR4, AR5. Okay? Five components. No? If you take a look at the plot kanina, kasi significant at 1, significant at 1, 2, 3, 4, significant at mukhang 5 to, no? But it was difficult to, ito pala, sorry, PACF, no? Kasi yung AR process, makikita natin sa PACF yan. Okay, so but it's difficult. It's difficult to identify anong model just based on the ACF and the PACF. That's why it's very useful, this one, yung auto.arima, no? And then the zero here means that, ano yung, di ba PDQ to class, di ba? If you recall, this is arima. So just so you recall, arima to, arima, P, D, Q. This is the AR component. Kaya nga natin kita mo dito, 5 AR daw. Oh. This is the MA component. MA. And this is the difference. Ang sinasabi niya, you don't need to difference. Okay? Bakit? Why no differencing? Kasi yung pinaplot natin class, yung minomodel natin, is already stationary. This is already DLAAPL, no? DLAAPL. Now, let's just so, magta-time na, no? Just so walang pakita to, no? What if, kunyari, hindi na tayo nag-differencing, basta sabihin natin, i-model mo nga yung ano, i-model mo yung, I'll call this, 111. Okay, just siguro 011 na lang. 011. So for 011, ang minomodel natin si Apple. Ha? What will happen? Okay, di ba si Apple hindi hindi stationary? Diba? If you recall, let plot, just to contextualize this, no? Plot AAPL. Okay, tingnan nyo. Plot AAPL, hindi siya stationary, di ba? So pwede mo bang i-model yan ng arima? Okay, the good thing with the forecast function ng auto.arima, pwede na. Kaso tingnan natin what will happen. So we're creating this object mod 011 auto.arima AAPL. Okay? So i-run natin tong dalawang to. Okay, and let's see what happens. Okay, here. All right. So medyo iba, no? Medyo iba. Ang AAPL natin, all right? So ang sinasabi niya 013. Eh bakit 013? Kasi ang sabi niya, okay, zero component yung AR, walang AR component. Okay? Tapos 1 yung differencing. So what is this telling us? You have to difference first in AAPL kasi hindi siya pwedeng i-model without differencing. Kaya may 1 dito. At saka ang lumalabas yung 3 MA, no? So ito ibang model to, no? Where we are modeling yung dapat Okay. So just to say what we did a while ago, ginawa natin kasi kanina difference ng log, no? So this is different, yung difference log, return siya. Ito naman yung Apple mismo. Kung Apple lang ang sabi niya, mag-difference ka dapat. Difference. Tapos let's see, what if we difference it niya? No? Okay. Let me run this, Control C, Control V. So I'm going to, pag dinifference ko ba itong si Apple, di ba meron na tayo nito, di ba? Do you have this? Yeah, may difference Apple na tayo. If I difference Apple, i-plot lang natin. Is this already stationary? Yes, it's stationary. So I'm going to create this 012, and then let's do the auto.arima for the difference Apple. Alright, so i-run ko tong dalawang to. What do you have? Okay, tingnan nyo class, no? Yung difference Apple is, okay, it's already time. Tapusin ko lang to class, sorry. 003. Okay, anong difference kanina dun sa AAPL? Sa kanina AAPL 013. Itong difference AAPL 003. It's the same, no? It's the same. Bakit same? Kasi yung kanina, ito, yung 011 natin, okay, ang sabi niya, i-difference mo muna. Kaya may 1 tayo dito. Dito, wala nang differencing. No? Bakit? Kasi stationary na yung DAAPL. Right? Pero, tingnan nyo class yung mga yung mga coefficients. Pareho lang. Yan, no? So, this is MA3 with drift. Okay, explain natin with drift later on. Okay? Ito with non-zero mean naman. Alright. So, let me stop there. Okay. Ito na lang pala, huling-huli. So, let me call this model 111A. No? So, we're modeling here, auto.arima, difference ng log AAPL. This is the returns. And then, mag-trace tayo. Trace is equal to true. If I run this, okay. What happens here is that magbibigay siya ng ng iba't ibang models. Okay. So take note, difference ng log AAPL to. So there should be no more differencing here. Notice na yung differencing na dito, zero lahat. Okay, bakit zero lahat? Kasi yung log returns na yan, stationary na yan, di ba? So no more differencing here. And then it gives us several models. Okay, and then ang sabi niya, ang pinaka-best dito is the one with, take note, this is your AIC. That's your Akaike Information Criterion. And sa modeling, if you're comparing models, yung pinaka-mababang AIC, that's the best model. And here is the model. Okay? Which is what we got a while ago, no? Arima 501, okay, with non-zero mean. So the best model is Arima 501. Okay? All right. So actually hindi pa tapos yan, so last na lang class. I-run na lang natin to, Control C, Control V. Kasi once we have defined that, all right. So what we do now is we dapat ito 501, no? So we're creating this model natin. Sabi natin Arima with DLAPL. Ang order natin 501, no? Okay? And include that mean is equal to true. And then let's run this. Okay, what do we have here? Okay. Ang question, are these the same as the figures that we got a while ago? And pareho ba siya? Itong AR1, AR2, MA3, tapos may MA1 component. Okay? Alright, so let's stop here, class. And I hope we were able to accomplish what I wanted to accomplish, yung pag-determine ng ng auto.arima, kung anong model dapat ang gagawin, no? And then we will have to check. Just like any regression, dapat check natin yung residuals kung okay to. Kung okay tong model na to. All right? Okay, so let's stop here. Any questions, class?
None po.
Okay, sige. So